Welcome back to Topic 7 for Algebra 2, Writing Linear Equations. In Part 1, we're going to focus specifically on how to calculate the slope of a line as well as how to calculate the rate of change. So first, let's do a little bit of algebra and review with what is slope. So oftentimes we see slope referred to in slope-intercept form, or y equals mx plus b. Now there are three different ways that we can calculate the slope. We have m equals, because m is the variable that we use to represent the slope, y2 minus y1 over x2 minus x1. Now these values are all points. We have a point x1 comma y1, and then we have a point x2 comma y2. Oftentimes we might see this in shorthand, such as change in y over change in x, because we're taking the difference, or the change, between y2 and y1 and x2 and x1. Or we might see it usually in a graphical sense as rise over run. So rise is our y values because we're going up and down on our graph, and then run is our x values because we're going left and right. Now there are a few different ways that we can see slope. There are four different types of slope specifically. We might have a positive slope, which is going uphill. We have a negative slope, which is going downhill, decreasing. We have a slope of 0, which is going directly across, just flat across. This is usually when, after we calculate the slope, we have a 0 in the numerator and then some other number in the denominator when we plug our points in. And then we also have undefined. So undefined is a vertical line, as we see here. So 0 and undefined, those are reciprocals of each other. So instead, we're going to have a number in the numerator when we simplify calculating our slope, but we end up getting 0 in the denominator. So this is where it's undefined. We cannot divide by 0. If you need more help with identifying the different types of slope, positive, negative, 0, and undefined, I highly recommend looking at Slope Dude. I will link it down below. Okay, now let's solve some examples that, without graphing, see if we can figure out what kind of slope we have. If our slope is rising, so if it's positive, if it's falling, or if it's negative, if it's horizontal, or a slope of 0, or if it's vertical, it's undefined. So in number 1, we have our points -5, 1, and 3, 1. So I'm going to first just label these, let's make this a little bigger, as x1, y1, and x2, y2. As you get more comfortable, you don't always have to label them, but I think in the beginning, as you're practicing, it can be really helpful to kind of keep track of everything. So we want change in y over change in x. Now I want to say I could have labeled the first point x2, y2 and the second point x1, y1. We will still get the same answer in the end. It's just you may deal with some negatives that will reduce further on. So change in y, I'm going to have 1 minus 1 over 3 minus a -5. Remember, a negative times a negative in the denominator is positive, so this turns to 3 plus 5, which gives us 8 in the denominator. In the numerator, 1 minus 1 is 0, so we have a slope of 0. 0 divided by 8 is 0. So this is a horizontal line, slope of 0. Moving on to number 2. We have the points 4, 6 and 4, -1. So here I can take change in y is -1 minus 6 over my change in x, 4 minus 4. I end up getting -7 over 0, which is undefined because we cannot divide by 0. So this is a vertical line. Finally, we have number 3. -3, 3, and 5, 8. So my change in y will be 8 minus 3 over 5 minus a -1. Again, that negative times negative gives us positive in the denominator. So we get 5 over 6. Now this fraction here is a positive fraction. It's positive 5 over positive 6. So this line is going to rise. Now we might deal with other types of lines. We might deal with parallel lines, or we might deal with perpendicular lines. Parallel is often referred to as, if we have this kind of double railroad tracks here, that's a line that, or that's a symbol that refers to parallel. If you think back to geometry, parallel lines have the same slope, so they're going in the same direction and they will never ever cross. So in order to do this, those slopes, that constant rise over run has to be the same. If we think about perpendicular, perpendicular is represented by like an upside down T. Perpendicular creates a right angle, if you remember back in geometry. And perpendicular slopes have opposite reciprocals. Now, oftentimes students get a little confused with the opposite reciprocal because they think that those two words mean the same thing. Opposite is referring to the sign, so it's going to change from either positive to negative or negative to positive. The reciprocal part refers to the fraction. So our fraction is actually going to flip. So the numerator becomes the denominator becomes the numerator. Remember though that every whole number is really over 1, so just keep that in mind when you are thinking about the reciprocal. Okay, let's solve an example. Let's see if we can tell whether the lines are parallel, perpendicular, or neither. Here we have line 1, which has these 2 points, -2, 2, and 0, -1. And line 2, we have -4, -1, and 2, 3. So I'm going to start by finding the slope for line 1, which if I plug into my change in y over change in x, we get -1 minus 2 over 0 minus a -2. Again, negative times a negative in the denominator gives me a positive. We end up getting -3/2. For line 2, we have 3 minus a -1 in our numerator and 2 minus a -4 in our denominator. Again, negative times a negative gives us a positive. We end up getting 4/6. Now this can be simplified because 4/6 can reduce, divide the top and bottom both by 2 to 2/3. So now what we're really trying to consider is my -3/2 and my 2/3. Here we notice that they are opposite reciprocals. So the lines are perpendicular. And when they cross, they end up making a right angle. Okay. Last but not least, we're going to talk about rate of change. Now, when I say rate of change here, I mean average rate of change. Later in calculus, you will learn about instantaneous rate of change, but average rate of change basically just means the slope. So if we look at the definition, slope can be used to represent an average rate of change. Or how much a quantity changes on average relative to the change in another quantity, so kind of comparing the two. A slope that is a real-life rate of change involves units of measure, such as miles per hour, degrees per day, etc., etc. So here we have an example. A red sea urchin grows its entire life, which can last 200 years. At age 30, the diameter of the sea urchin was 11.9 centimeters. At age 110, the diameter of the sea urchin was 15.5 centimeters. What is the average growth rate of this urchin over the given period? So we have two things. We're dealing with our age, and we're also dealing with centimeters. So this is where you need to think logically in order to kind of differentiate between which will be your x variables and which will be your y variables. So remember, when we have our slope, we have change in y over change in x. So would it be common to have years per centimeter or centimeters per year? It's more realistic to have centimeters per year in terms of measurement. So we're going to measure the change in centimeters over the change in years. This will tell us that the years will be my x values. So 30 will be my x1 and 110 will be my x2. Then the centimeters will be my y values. So 11.9 centimeters is going to be y1 and 15.5 centimeters is going to be y2. Now all we have to do is just plug in. So in my numerator, I'm going to have 15.5 minus 11.9. And again, just make sure your x and y variables are corresponding, so we keep our x2s with our y2s and our x1s with our y1s. Then our age will be in the denominator. We'll have 110 minus 30. Now all we have to do is just simplify. 15.5 minus 11.9 gives us 3.6. And in our denominator, 110 minus 30 gives us 80. So we can simplify this, and this gives us 0.045 centimeters per year. Now the division symbol is used to say per, so this is why we keep our units. And this is really per 1 year. But remember, 1 is a humble number, so it's not always written. So the final answer is the average growth rate is 0.045 centimeters per year. And that's it. Thank you so much for watching part 1 of topic 7 for Algebra 2 on writing linear equations, specifically focusing on the slope and rate of change.